We're looking at trigonometric equations. We've got a very specific one here, sine 2x is equal to a half, and we're going to try initially to find the values for it from 0 to 180 degrees. So we're just limiting it a little bit. So the first thing I'm going to do, I've got a graph here of sine theta, so I'm going to use that. In order to use that, what I'm going to do is I'm going to change this sine 2x equals to a half to sine theta is equal to a half. As you can see in green, I've already highlighted where the half is on my graph, so it's just there, and we just bring a line across, and if I drop down where it meets my graph, we're at 30 degrees and 150 degrees. So I can say straight away sine theta is equal to a half when theta is equal to 30 degrees or when theta is equal to 150 degrees. Now in each case, I can now change theta back to 2x, and I can say 2x is equal to 30 degrees, therefore x is equal to 15 degrees. And likewise, with the second solution, I can change this to 2x is equal to 150 degrees, therefore x is equal to 75 degrees. And that's a solution in this range from 0 to 180 degrees. Now we're going to look at this particular range here. We've got from minus 180 to x to 180 degrees. Now what's going on there? Where's those minus numbers coming out of? We don't appear to have any on our graph. Well, we can just extend our graph. Look at this. So I can come back, go over my work, and I get something like this. And so from that, what we can do is if we look at sine theta, going back the way, sine theta is equal to a half. If I was to extend back my line, what we suddenly have here is we've got two more values. We've got two more values which would drop down there and there. Let's just put in that axis nice and lightly so we can see what. Now what we need to do is we need to figure out where or what values these are. So that's pretty straightforward. We can do that pretty quickly. The next theta, if we look at the first one of these, that's like that one transformed back. Well, how far back? Well, it's a full 360 degrees. So 30 degrees minus 360 is minus 330. So theta is equal to minus 330. And that's just this, basically. So 2x is 30 degrees here. So we've got 2x equals 30 degrees. We can say down here 2x is equal to 30 minus 360. Same as this, minus 330. Therefore, my x is equal to half of this. So half of 330 is minus 165. So that's one solution. But we do have another one coming down here. And again, that's the 150, which has been transformed back 360. So we can use that one. So that's theta is equal to, well, 150 take away 360 is 210, minus 210. So we'll just do that just to be really clear. 2x is equal to 150 minus 360. 150 minus 360 is minus 210. Therefore, my x is equal to minus 105. And now what we have is 4 solutions in this range. Where we had 2 for the first one, we now have 4 here. So we've got x is equal to 15 degrees, x is equal to 75 degrees, x is equal to minus 165 degrees, and x is equal to minus 105 degrees. And so we've seen here, when we change the range, what happens. And we just see that it has just shifted. Well, now we're going to look at all solutions and what would happen in all solutions. Just a little technical term here. This is known as the general solution. Okay, and that's a very key mathematical term, the general solution. And you need to maybe just be familiar with this. You might be asked to find all solutions. It means find the general solution. Okay. The general solution is that this wave just continues, and it could continue all the way along there, or it could continue all the way along there, and it'll just keep going. And how many values at a half would you have? Well, as we saw when we extended it into this one, we just subtracted 360 degrees. we could have added 360 degrees if it was going in the other direction. So let's just take a look at that. So we have two values for theta. We've got theta equals 30 degrees from our first solution, and we've got theta equals 150 degrees. And what we could do is we could say that it's 30 degrees plus 360, but any multiple of 360. So we could say plus 360, and to give a multiple, we say n. So like the 360 times table, if you will, 360n. And the same, we can say the same thing down here, 360n. We're just adding 360n. So every time we move this graph, we're adding or subtracting 360. So we can then generalize that down for our 2x. So 2x is going to be equal to this all divided by 2. So 30 plus 360n all over 2. And similarly here, 2x is equal to 150 plus 360n all over 2. And in each case, we can just continue that down, just simplify it. And so we get x is equal to, well, 30 divided by 2 is 15, which we would expect, plus 180n. And here we've got x is equal to 75 plus 180n. And that makes sense because we're talking about the graph of 2x where this would appear twice in one period. And so that's the general solution right there. We'll just put a little box around it to make it really clear. An interesting little thing, an aside to point out is, if I had done the general solution initially, I could have found the solutions for both parts 1 and 2 trivially, very easily. Okay, if I was looking at part 1, well, I wouldn't have been adding anything on. So n would have been 0 in both cases. So I would have had 15 plus 0, 75 plus 0, which is these two solutions right here. Likewise, in this scenario, n would have been minus 1 because we were going back, we were subtracting. So we would have had 15 minus 180 and 75 minus 180, which would have given me these two solutions here. So the general solution is really quite useful if we get that one first.